This is Steve Fowkes welcoming you to the 7th video. Finally, we get to the point where the Alzheimer's cascade goes mainstream, where it becomes recognizable as Alzheimer's disease by doctors and researchers. Microtubules are assembled from alpha and beta tubulin proteins using GTP as the energy source. First, GTP is used to assemble dimers. Then another GTP is used to assemble each dimer pair into multiple strands, 13 of which spontaneously bundle into each microtubule. Microtubules serve as a transportation network, just like a highway system where semi-tractor trailers haul groceries from a central warehouse to local supermarkets. Microtubules are polarized, meaning that they have direction and always point from the nucleus of the neuron down the axons and dendrites to the nerve termini, in other words, from the central warehouse to the neighborhood stores. There are two kinds of semi-tractor trailers. The kinesin motor proteins attach to the microtubule facing forward and moves outbound material from the nucleus to the terminus. The dynein motor protein attaches backwards and moves other materials inward bound towards the nucleus. Beta tubulin contains multiple sulfhydryl groups, two of which are immediately adjacent to the active site for GTP binding. In the presence of mercury, GTP binding is inhibited and microtubule assembly is prevented. This toxic effect of mercury also disassembles assembled microtubules into tubulin pieces. Beta tubulin binding is known to be inhibited in Alzheimer's disease. GTP binding by beta tubulin is also known to be inhibited by root canal teeth. This not well-known finding suggests that a comprehensive dental evaluation by a practitioner armed with a beta tubulin sensitive assay should become a high priority part of an overall clinical evaluation for Alzheimer's disease. It also suggests that people interested in prevention should either avoid root canal procedures in favor of extraction or use more sophisticated root canal procedures utilizing ozone to sterilize dental tubules of anaerobic bacteria and calcium oxide slurries to fill dental tubules. One of the supplemental slides at the end of this presentation has additional details about one known root canal neurotoxin. One last item. There is test tube evidence that mercury toxicity towards microtubules is aggravated by zinc. The clinical import of this finding is not clear, but additional details of this finding are presented in one of the supplemental slides at the end of this presentation. There are other Alzheimer's disease-related phenomena that relate to mercury toxicity that we have yet to discuss. This will begin with tau protein. One of the most important of the Alzheimer's phenomena that have not yet been mentioned are neurofibrillary tangles, which are made up of microtubule-associated tau protein. These tangles are visible under microscopes and are one of the hallmark signatures of a postmortem Alzheimer's diagnosis done at autopsy. The tau protein in these tangles has been determined to be overphosphorylated, which is a mid-term manifestation of Alzheimer's disease caused by earlier destabilization of the kinase phosphatase enzyme systems that have already been mentioned. One of the most well-known manifestations of Alzheimer's disease is beta amyloid plaque, which is predominantly made up of beta amyloid protein. This plaque is well known because it is highly conspicuous under microscopes, a dominant feature at autopsy, and was one of the first signs identified as being associated with Alzheimer's disease. However, beta amyloid plaque does not accumulate until later stages of Alzheimer's disease and is therefore not likely to be causal influence in the underlying pathology. A far more important factor that is critically associated with Alzheimer's disease risk is inflammation. However, this subject will be postponed for more detailed discussion later in the presentation. Another risk factor that is well known is the genetic risk from ApoE. Although ApoE genotype is probably not anywhere as important as inflammation, it is hypothesized to have a direct bearing on mercury status and is therefore intimately tied to the theme of this presentation. There are 3 variations of the ApoE gene in humans. We get one ApoE gene from each parent, so we each carry 2 ApoE genes. ApoE3 is by far the most common form, and roughly 90% of the population carries one copy of the ApoE3 gene, and roughly 60% carries 2 ApoE3 genes. There are 2 less common variant ApoE genes, ApoE2, which is protective regarding Alzheimer's risk, and ApoE4, which increases risk. So, on the chart of all possible combinations of these genes from your mother and father, having 2 of the high-risk genes has the earliest onset. Having only 1 of the high-risk genes is the next earlier onset. Having 2 medium-risk genes, or 1 high-risk and 1 protective gene, gives even later onset. And having 1 protective and no high-risk gene provides the latest age of onset. Having 2 protective genes would presumably be even later onset, but that is so rare that there is no statistical evidence to prove it yet. Regardless, the risk is oriented diagonally across the chart. The ApoE genes code for a protein, which is made up of a chain of amino acids. When the amino acid sequences of these proteins are compared, all but 2 of the amino acids are identical. The 2 that are different lie at positions 112 and 158 on the chain. The protective protein has 2 cysteines at these positions. The most common ApoE protein has 1 cysteine and 1 arginine, and the high-risk protein has 2 arginines at these positions. The amino acid cysteine contains a sulfhydryl group just like glutathione. Is it possible that these cysteine residues could bind to mercury and decrease the brain's mercury burden? The correlation seems too perfect for this not to be the case. The arrows for cysteine and the Alzheimer's risk are exactly identical. Now let's return to a more detailed discussion of inflammation. This concludes the genetic discussion. Now is the time to advance to Part 8.